For part A, the force is acted upon this hoop is F of G, contact force, and F of K because it's rolling. For part B, we use conservation of energy, and we know that our moment of inertia of the hoop is just mr squared. And we convert the omega into v squared over r squared. R's cancel, as well as our m's. So we're left with GH equals 1/2 v squared plus 1/2 v squared. This equals to 1, so we just square root it, because it's just 1. So our v would just equal to GH from the bottom. We have part C. Part C is just the ratio of KE rotational over KE total. And so this would just be in turn equal to this 1/2 v squared, because KE rotational is just 1/2 v squared, as we found up here in the conservation of energy. And then the total KE would be 1, because this plus this is just 1. So it's just v squared, cancel. So it just equal 0.5. This is our ratio. And for part D, since we know the function acceleration equals g sine theta over 1 plus coefficient, we know this formula. So since gravity is the force pushing from the center of mass, which causes the FGX to push it forward, so depending on the angle, the FGX could change. And this only happens when the slope is curved, which in this case, the slope is curved. If it was a linear, the A would be constant because the force is constant due to the angle of the FG. But since the angle of the FG is constantly changing due to the slope changing as a curve, the acceleration also changes with the force. Now for part E, asks for if you double the height, of the thing, it would double the velocity. I would disagree, like how I disagree with the acceleration being constant. I would disagree with the velocity being doubled, because if you plug this in, u as square root g2h, you can take out the 2, square root of 2, and gh u, and then this equals to that. So VCM square root 2 VCM old. So the square root of 2 is actually less than 2, so it can't be doubled. And for E, and then for F, part F, for part F, for part F, for part F, it would ask for the time it would take for it to drop from HO down here. So this is what we're finding the time. So for the time, we would just do HO equals 1/2 GT squared plus VIYT, but since in this case there's no VIY, we just cancel it. So HO would just equal to, so then we just isolate for T, which we times 2 by both sides, cancel, and divide by G. So we're left with TG equals T squared, and T square root of that is just square root GH over G, 2H over G. This is what our time function is, for how we find time. And then next we find the distance function. So for g, we also use displacement function, 1/2 a t squared plus vi xt. This acceleration cancels because there's no acceleration in the x direction, so it would be d equals vi xt. And we know that vix is just equal to v, or just square root of gh. So we do d equals square root of gh. And then we know our time function is actually just square root of 2h of g. And g's cancel out. So we're left with square root of 2h and square root of h. So our d equals just 2h and h height. For part h, it asks, will the angular speed increase as it leaves the edge, since the hoop is in the air? The only force acting upon this object in the air is just g, gravity. But since the gravity is not perpendicular to the radius of the hoop, there's no torque, as you see in that torque equals force perpendicular radius. There's no force perpendicular to the radius, so there's no net torque. So net torque equals 0, meaning that the omega, or the angular speed, actually stays constant throughout the flight. And for I, or let's write I right here. For I, since it's asking for clean and concise paragraph, if you were to switch the hoop in the solid hoop, and which would travel greater distance. So basically, since both have different inertias, both object has different inertias, the object with the least inertia moves a farther distance because the object who needs more inertia uses more energy to be converted to rotational speed to rotate. As for the inertia, the least inertia, it takes less energy to rotate, so most of its energy goes to the linear KE. This therefore means that object solid disk of 1/2 m, or squared will have a faster initial velocity, meaning it would travel a greater distance.